So much of what we say in life really has a hidden message that we don't explicitly state. It's hard for me to imagine that a robot could capture the complexity of human communication, no matter how sophisticated the programming.
If I have a robot and all it has to do is one-way communication,
Hello.
that uses some of those basic mechanisms.
Hello, welcome to Human-Computer Interaction Lab.
The moment you're thinking about conversation and exchange, then it's going to require this much more complex, interactive kind of exchanges.
I need to be able to decode the expressions on your face. Also, you're giving me cues in your voice.
Really? Yeah, that's cool.
I could say, you bought those shoes. That's a statement of fact. Or I could say, you bought those shoes. Or I could say, you bought those shoes. And they mean different things.
If I want to call your attention to something, I'll point at it. And you look there, I know that I have achieved my goal.
You also give me eye gaze cues. And to be able to process all those cues is just an impossible task. But that's kind of the way our brains are wired. It is not happening at a conscious level. So what's going on in the brain when we're doing all this, we don't know. It's hard to imagine a program that could capture the universe of those variables.
That's the challenge for Professor Bilge Mutlu and his computer science team at UW-Madison.
There's a whole range of ways we could make it even more sophisticated with like more machine learning from the data, more artificial intelligence methods.
If you want to build robotic technology that will achieve the kinds of visions that we have, artificial intelligence is necessary to grow into having all those skills.
My definition of artificial intelligence would be a robot that can react in an adaptive way to its environment.
You can't encode everything that a human does. Some of that has to be learned. What we want is to have some basic skills programmed in, hard-coded in, but also the ability to learn and adapt.
You need something that can understand language and interpret some meaning behind the language.
Who are you?
My name is Wakamaru, but you can call me Waka.
You need something that can make decisions for itself and reason about the world.
The robot learns and adapts itself to what it actually sees.
And I think there is that element of learning from past mistakes that feeds into artificial intelligence, much the same way that it feeds into human experience and human intelligence.
It is learning.
And the smarter the technology, the better supports they can provide.
Something like a caretaker robot, I can see where you would want that kind of adaptive ability. Being able to say, this is outside the norm, what do I do now? Rather than saying, this does not fit the 6 criteria, I just simply shut down. The danger there is whether it would make the same decisions we would for the same reasons. We see this a lot in military drones, where there's a lot of discussion whether it's acceptable to have a drone that can launch strikes on its own without human input evaluating targets.
It brings up a lot of different ethical questions. The self-driving car is a good example. It certainly brings up some ethical concerns, like how do you want it to behave if it predicts it's going to get in a car crash? Who does it save, the person in its car or the person in the other car?
I think the slippery slope is, sort of once we program these to learn, what's to stop it from programming itself to override all human input? What happens if this accidentally becomes something that we weren't expecting?
I don't want to create a human or a human replica. And I think that naturally draws a line, that you are not making something that has feelings, that has its own goals.
I think they do have to be aware of the question of sentience, because once you have sentience, even if it's accidental, then you have the other question of not even how it interacts with us, but where does it fit into our society? Does this sentient entity now have rights of its own?
I need some help with this.
And those are all still open, important questions.
Getting to that point is just so far out that I think by the time we are close to having more complexity, we might be able to better define the problem, because I don't think the problem is well defined right now. Sometimes we need to develop technology, put it out there, carefully watch, see what vulnerabilities emerge in the field, and go back and improve it. It's going to be back and forth, and that iterative process, it helps you address any ethical concerns. There has to be a lot of experimentation and understanding and probing before we can say that it's ready for Christmas.